Nucleophilic substitution reaction. What is substitution reaction? Did I give an introduction in the last class? Nucleophilicity. I gave an introduction. Nucleophilicity, leaving group ability. Introduction is over. Right? Watch that video. Right. Nucleophilic substitution reaction is classified into. I given definition. Once again, I'll revise the definition also. The reaction in which one nucleophile is substituted by another nucleophile is called as nucleophilic substitution reaction. One nucleophile is substituted by another nucleophile. I give an example, general reaction and example also. Watch that video once again if you want. Right. Nucleophilic substitution is classified into SN1, SN2 and SNAR. Aromatic nucleophilic substitution reaction. Aromatic nucleophilic substitution. SN1, SN2 and SNAR. 3 categories. Clear? First two are most important. Last one also moderate important. Right? Let us start first one. SN1. SN1. Okay. Right. First of all, let us see the abbreviation. Abbreviation. How to read this? One represent unimolecular. Unimolecular nucleophilic substitution reaction. Unimolecular nucleophilic substitution reaction. What is unimolecular? We will learn now. Unimolecular nucleophilic substitution reaction. Abbreviation for SN1. One represent unimolecular nucleophilic substitution reaction. Okay. Now see the points. First of all, try to understand the theory points. Okay. If you are perfect in the theory concept, then you can do the questions. Right. Every point is most important. It takes place in SN1. SN1 takes place in 2 steps. It takes place in 2 steps. 2 steps. See, reverse. 1 means 2 steps. 2 means 1 step. Remember like that. Clear? It takes place in 2 steps. Step 1 is the formation of carbocation. Step 1 is the formation of carbocation. Step 2 is the attack of nucleophile. Step 2 is the attack of nucleophile. Right? Next, rate of SN1. The rate of SN1 is directly proportional to concentration of alkyl halide. It is called as substrate generally. Substrate means it is the reactant in a reaction. Another name for the reactant is substrate. In SN1, SN2 reactions, we consider reactant as a substrate. Substrate nothing but a reactant only. In a reaction, left hand side what is present? Reactant. Right hand side what is present? Product. Reactant only, substrate. Okay. So rate is proportional to substrate or concentration of alkyl halide only. Why I mentioned that word only? I'll tell you later. Is there any nucleophile in this expression? Is there any nucleophile? No. Remember that point. Rate of SN1 only depends on the concentration of alkyl halide or substrate only. But it do not depends on nucleophile concentration. Most important point. We will use that point later. Okay. So SN1 is a 2-step process. Step 1 is the formation of carbocation. Step 2 is the attack of nucleophile. Rate of SN1 is proportional to concentration of alkyl halide only. Shall we go to next page? Online students. The order of reactivity. The order of reactivity of alkyl halides, most important point. Order of reactivity of alkyl halides towards SN1 is 3 degree alkyl halides are more reactive. 3 degree alkyl halides are more reactive than 2 degree alkyl halides. 2 degree alkyl halides are more reactive than 1 degree alkyl halides. Important reactivity order. Tertiary alkyl halides readily participate in SN1 reaction than 2 degree alkyl halides. 2 degree alkyl halides readily participate in SN1 than primary alkyl halide. Most important reactivity order. Right, next, racemic mixture formation takes place. Racemic mixture formation takes place. What is racemic mixture? In the first year stereochemistry, equimolar mixture of dextro and levorotatory is called as racemic mixture. Racemic mixture is optically inactive due to internal compensation, first year isomerism concept. Racemic mixture means equimolar mixture of D and L, dextro and levorotatory. What is dextrorotatory? What is levorotatory? See, this is optically active compound. What is optically active compound? Let us consider a beaker containing glucose solution. This is a beaker containing glucose solution. Pass the plane polarized light. Plane polarized light means light which passes through one plane. Okay, laser light, you know, laser light. Pass that PPL, plane polarized light, through this solution. After passing through this solution, okay, when it comes out, it changes its direction. It bends towards right or it bends towards left. This solution is rotating the light towards right or left. This chemical compound is rotating the light. It is changing the direction of the light. This is called as optically active compound. The compound which rotates the plane polarized light towards left or right is called as optically active compound. And the phenomenon is called as optical activity. Phenomenon is optically active compound. Okay. Then what is dextrorotatory? The compound which rotates plane polarized light towards right side. Dextrorotatory. What is levorotatory? The compound which rotates plane polarized light towards left. What is a racemic mixture? The mixture in which both dextro is present and levo is present. Then what about net rotation? One is rotating right, another one is rotating left. Then net moment is 0. That's why optically inactive. So this is some introduction of first year isomerism. Clear? Okay. This is also very, very important. Which of the following is true? Which of the following is false? In SN1, racemic mixture takes place. Correct statement only, na? In SN1, racemic mixture takes place. In SN1, rate depends on concentration of nucleophile. No, in SN1 rate depends on concentration of alkyl halide only. Theory also very, very important. Clear? Right. Racemic mixture formation takes place. Let us see one example. CH3, Cl. OH minus is the nucleophile. First I will write the general reaction, complete reaction. This is nucleophilic substitution or not? Yes. Nucleophilic substitution. Because one nucleophile is substituted by another nucleophile. Nucleophilic substitution. This is 3 degree alkyl halide. 3-degree alkyl halide, right? Let us see what is the mechanism, how we will get this. Clear? How we will get the product alcohol. This is nucleophile. Cl is the leaving group. Cl is the leaving group. In the last class, the last lecture, we completed what is the leaving group, leaving order also, leaving ability of order, nucleophilicity also. Clear? Right. See, when you get the question on SN1, what you have to do? What is step 1 in SN1? What is step 1 in SN1? Online students, what is step 1? Formation of carbocation. Saad, correct only, no? Saad, Ubaid. Saad and Ubaid, correct only? Now you tell me, in pink bond, pink color bond, how many electrons are present? 2 electrons are present. What you have to do? See, orientation is very, very important. So many students will read SN1, one-step mechanism, two-step mechanism, ready proportional to this, that. Okay, everyone will buttify that, clear? But how to do the question? Orientation is very, very important. First, remove halogen along with the bond. This is very important part. Remove halogen along with the bond. Along with the bond means halogen is taking its own electron and the electron of carbon also. Remove halogen along with the bond. That is very important point. Means this carbon is losing its electron or not? Halogen is taking its own electron and electron of carbon also, right? Then carbon will get a positive charge. This is carbocation or not? What is step 1? Read. What is step 1? Formation of carbocation. Carbocation is formed. And you tell me, just a second, all of you. This is one atom. This is another atom. Both are held together by a bond, by sharing the electrons. These are having some stability. What is the cause for chemical bonding? To attain the stability only, no? This atom and this atom are sharing the electrons. Both atoms are in the stable state. Now, what we are doing here, forcefully we are breaking the bond. Chlorine forcefully taking the electron of carbon also, making carbon unstable, right? Is carbon is having electron? No, that's why it is having positive charge. What chlorine is doing? Forcefully taking its electron of carbon. This is chlorine electron only, no problem. If chlorine takes its own electron, then there is no problem. But what chlorine is doing? Forcefully taking electron of carbon also. That's why carbon is becoming unstable. Carbocations are unstable species. Intermediates are unstable species. Clear? So this is a late process. Why it is a late process? See, chlorine is forcing carbon to, hey, give your electron. But carbon is saying, I don't give my electron. But chlorine is taking forcefully. It is slow process or not? Carbon is not giving readily, hey, take my electron. But carbon is losing electron forcefully. Forceful in the sense, it is not liking to lose its electron. So it is a slow process or fast process? Tell me. Bond breaking is a slow process always. Bond breaking is slow process. So it is a slow step. It is a slow step. Very, very important. Step 1 in the SN1 reaction is slow step, and this is called as rate determining step, RDS. Slow step. Why it is called RDS, rate determining step? See, one car is going in front of you with 150 to 200 kilometers. Can you read the properties of car? It is going very fastly. Can you read the properties? Can you see the driver face? Can you note the number plate number? If car goes very fastly, if car goes slowly, then you can analyze the car. You can record anything. If reaction takes place slowly, then you can find its speed, rate, everything. So rate determining step. For slow reactions, we can calculate the rate. For fast reactions, we cannot calculate the rate. That's why slow step is called as rate determining step. We can study slow reactions. We can find the rate of slow reactions. That's why slow step is always called as rate determining step. Now you tell me in SN1 which step is RDS step 1 or formation of carbocation step. Right. Step 1 is completed. Next step 2. Step 2. Step 2. What is step 2? One, see the main points. Attack of nucleophile. This nucleophile attacks carbocation. We will see the stereochemistry later. First I am giving plain information. Again here some stereochemistry concept is there. At the end I will explain. Right. Right. You tell me what is the nature of reaction between sodium cation and Cl negative anion, fast reaction or slow reaction? Cation and anion, positive and negative, attaches fastly. So this is a fast step. Slow step, fast step. Attack of nucleophile is a fast step because positive negative attachment is very fast. Fast step. So you cannot study this. So it is not rate determining step. Online students, are you getting? Saad, Hadiba, Obed, you, Obed. Once again, see, now only learn what is SN1 abbreviation, unimolecular nucleophilic substitution. In how many steps it takes place? 2 steps. Step 1 is formation of carbocation. That is slow step or fast step? Slow step. What is step 2? Attack of nucleophile. Attack of nucleophile. Rate depends on what? Concentration of alkyl halide only or concentration of substrate only, not on the nucleophile. Not on the nucleophile. I use this pointer when I required. Next, what is the order of reactivity? 3 degree alkyl halides are readily reactive. So what you have to do after the class, take white paper, write all these points, then you will get concept, then you can do the questions. Clear? After the class. Right, next continuation. Okay, I given about the mechanism, how carbocation is formed and what is a slow step, what is a fast step. Clear? Next continuation, factors affecting SN1. Questions depends on these factors only. If you get these factors, then you can answer very easily. Clear? Factors affecting SN1. Factors affecting SN1 reaction. Factors affecting SN1 reaction. The following factors which affect the SN1. First factor, nature of substrate. Second factor is nature of leaving group. Already we completed leaving group ability in the last class. Third one, nature of solvent. And fourth one, nature of nucleophile. These are the factors which affect SN1. This is a special case actually. See this one, nucleophile case. Most dominating is nature of substrate, and that purely depends on the GOC knowledge. Now only you can realize. See how I link alkyl halides to resonance applications. First one, nature of substrate. Nature of substrate. Sorry? That is later. Just we begin. We started now only. No? Later you can differentiate what is SN1, what is SN2, right? Time will require, okay? It takes some time, Adiba, to understand, okay? First one, nature of substrate. I will cover everything, don't worry. Nature of substrate. First, observe this point. The alkyl halide, substrate means alkyl halide. The alkyl halide which can form stable carbocation, readily participates in SN1. Most important point, important statement. Okay. You will get 4 options in the question. Which of the following alkyl halide readily participates in SN1? Then what you have to check? You have to check which alkyl halide forms stable carbocation. Clear? First factor is nature of the substrate or nature of alkyl halide. The alkyl halide which able to form stable carbocation, that one only readily undergoes SN1 reaction. Let us see one example. You know about your GOC knowledge, right? Let us start. This is first alkyl halide A. This is second alkyl halide. I said one point to you during solving of the questions related to SN1. What we have to do? We have to remove halogen along with the bond. After that, we have to write carbocation. Be habituated for this process. Clear? Don't go by your own plans. Clear? Here, remove halogen along with bonds and write carbocation. Now analyze which carbocation is more stable. See, link to inductive. That is the specialty of second year organic. Completely depends on the GOC of first year. Which is more stable carbocation here? Why A is more stable? 3-degree carbocation. This is 3-degree carbocation. 3-degree carbocation is more stable than 2-degree carbocation. Now you tell me, alkyl halide A and alkyl halide B. Which alkyl halide is forming stable carbocation? A. So A readily participates in SN1 reaction. Clear? What I given one statement, the alkyl halide which can produce stable carbocation, that only readily participates in SN1. For that you should have idea about the stability orders. So as soon as possible, means by tomorrow class you should complete GOC. You have to complete GOC. This is very easy question, right? Everyone will answer this. Next. Example. See the model question. Which of the following alkyl halide readily participates in SN1? First option. What is its name? And the classification I given the names also. Means you didn't read the notes. Its name. You will get names only. NEET students will get names only. Due to shortage of paper, they won't give the structures. I hope we will perfect by tomorrow in nomenclature and in GOC also resonance. Okay, once again read the classification. I given names there. Its name is benzyl chloride, benzyl group, benzyl. You will get names only. Okay, remember. Benzyl chloride, benzyl chloride, and this is Srujan? Alkyl chloride. Very good. Alkyl chloride. Benzyl chloride and alkyl chloride, which is more reactive towards SN1. Follow the procedure. Yes, benzyl chloride. What is the procedure? Remove halogen and form carbocation. Until you will get perfection, follow the procedure. Clear? Remove the halogen. Obed and Saad, are you getting both of you? Obed and Saad. Obed? Yeah. What is the procedure? Remove halogen along with the bond and write a positive charge. Remove halogen along with the bond and write positive charge. Now analyze which is stable carbocation. In GOC, I given overall stability order in the video lectures also. You can see overall stability order is given to you. Benzyl carbocation is more stable carbocation than allyl carbocation. This is less stable compared to benzyl carbocation due to extended resonance, continuous resonance, extended or continuous resonance. See, this will shift to this side, this will shift to this side, this will shift to this side. Extended resonance due to extended resonance. Adiba, did you get now? You asked one question before that. This one only, no? Adiba? This is not extended resonance, only limited resonance. One time only bond shifting is taken. Resonance is present, but only one time, not extended. So benzyl carbocation is more stable. So which halide is more reactive? Benzyl chloride. Benzyl halide is more reactive towards SN1. Why? Benzyl chloride will form stable carbocation, extended resonance is present. So benzyl chloride is more reactive towards SN1 than allyl chloride. Allyl chloride. Simple trick. Remove halogen, observe the stability orders. Okay. Right. Bhakti, guess who is coming? Who is coming now? You don't know our code? Skullman. Skullman is highly dangerous. 10 volt, 100 volt and 1000 volt. Our codes. 10 volt means less important. 100 volts means very important. 1000 volts means very important. See. 3 alkyl halides are there that never participate in SN1 and SN2. Substitution is not possible for that halides. What are that? What is its name? Go to classification. What is its name? Don't know the name? Very good. Vinyl chloride, vinyl group. This group is called as vinyl chloride or vinyl bromide or vinyl iodide, vinyl. And this is aryl. Don't say benzyl, aryl. Blunder mistake. Don't say benzyl. Benzyl means that one, previous one. Aryl halide. Aryl halide nothing but chlorobenzene, bromobenzene, iodobenzene. Commonly called as aryl halides, aryl group, aromatic, aryl halide, aryl chloride, or simply you can consider it as aryl halide or chlorobenzene, aryl halide or chlorobenzene, aryl chloride also you can call, right? Vinyl chloride, aryl chloride, and another one. Online students, once look at this. Can you able to see this area? Online students, this area. Now see, I am highlighting two carbon atoms, right, and I am writing one bond in the plane, above the plane, sorry, not in the plane, above the plane. Like this I am writing. One bond is coming out of the plane from this dot. Another bond also coming out of the plane, means three-dimensional out of the plane. Now the two are joining. The two are joining. Now can you imagine like this? The two are joining. Okay. But we cannot represent on the two-dimensional board, so I am writing like this. Now this yellow vertex is present. Tell me, what is the position of yellow vertex? In the space or on the board? In the space. In the space. In the space. It will come out. It will come out. Clear? These two white dots, sorry, these are bridge heads. It is acting like a bridge. It is acting like a bridge. So this is bridge head, this is bridge head. Bridge head carbon, bridge head carbon. Very, very important. If I attach halogen to bridge head carbon, that is called bridge head halide. Bridge head halides. Bridge head halides. Bridge head halides. Bridge head halides do not undergo SN1 as well as SN2. I'll give the reasons also, because reasons also very important. First of all, write what is the conclusion. Tell me. Vinyl halide, aryl halide, bridge head halide do not undergo SN1 as well as SN2. We will discuss SN2 later, but write a statement here. Do not undergo. Do not undergo SN1 and SN2. Do not undergo SN1 and SN2. The reason is important. Reason is important. Okay. What is the meaning of substitution reaction? Substitution means the reaction in which one atom is replaced by another atom. This is called as substitution. This is old atom, new atom is coming. Substitution. Now you tell me, when it will come to this place, if it leaves, then new atom will come into that place, right? If this atom do not leaves, it is permanently sticking here only, then will it come? No. Clear? Correct only, no? Remember this part. Let us take vinyl first. If chlorine leaves, then nucleophile will come into the place of chlorine. Clear? Right. Now before that you tell me. This is single bond, double bond, triple bond. Which is strong bond? Triple bond. Next, weak. You can break this easily, right? Can you break now? No. Now, highly difficult, right? Breaking of single bond is easy. Then double bond, then triple bond. Clear? Now, this chlorine atom, you know everyone about resonance. Resonance. What is the structural requirement for resonance? Structural requirement for resonance. Say tomorrow after watching today. Lone pair participates in resonance. Lone pair participates in resonance. Due to resonance, see. CH2 double bond CH. Double bond is forming. Double bond is forming between. Double bond is forming between carbon and halogen. Double bond. Now you tell me, Cl is tightly held to carbon through double bond. Can we break this? Will it leave? No, it won't leave. It won't live. Then how another atom will come in the place of Ca? So substitution is not possible. This is called partial double bond character. Direct statement will come due to partial double bond character. Partial double bond character, PDC. It is abbreviated as PDC. Due to PDC character, partial double bond character, vinyl halide do not participate in SN1. Because of PDC, partial double bond character, chlorine is sticks to the carbon tightly through double bond. Why? Due to resonance. Due to resonance. The resonance is present. Watch the video for conditions of resonance, structural requirements for resonance. So reason also very, very important. Vinyl chloride. Now can you do one question on this? Any doubt? Similarly, reason is same for aryl halide also. In aryl halide also, due to PDC character only. Look at this. Chlorine lone pair electron enter into the resonance. Okay. Negative charge. Here also PDC character, partial double bond character, PDC. And the bridgehead halogen is a separate category. Just you remember, reason is not important for that. According to Brett's rule, positive charge at the bridgehead is unstable. That is the reason. Brett's rule, BREDTS. According to Brett's rule, positive charge at the bridgehead is unstable, but that reason won't come. Clear? Just you remember the example. Which of the following do not undergo SN1 or SN2? Remember that 3 examples. Right. What is the reason for vinyl halide? Why vinyl halide do not participate in SN1? Due to PDC. Say answer directly, PDC. Partial double bond character. Answer this question. How many of the following? Do not undergo SN1. You give the tick marks for the compounds which do not undergo SN1. Just you say the answer A, B, something like that. Okay. More than one correct answer. No. I'll tell you. Coming to that point only. Vinyl bromide also. Vinyl iodide also. You are asking about halide or chloride? No. Bromide iodide also. Bromide iodide. Give the ticks for the molecules which do not undergo SN1 reaction. Where PDC is present, when PDC is present. Where PDC is present and when PDC is present. More than one correct answer this is. Okay. In iodobenzene, PDC is present or not? Present. So it do not undergo SN1. So give the tick mark. Do not undergo. Why? Iodine lone pair participate in the resonance. Next B. Undergo or do not undergo? Do not undergo. Chlorine lone pair participate in the resonance. Not only vinyl, always. If halogen is directly connected to double bond. If halogen is directly connected to double bond, PDC takes place. Also do not undergo. Next, bridge head halide, do not undergo. That is a statement actually. According to Brett's rule, positive charge at bridge head is unstable. That's why it do not undergo SN1. So first three. Then what about D? Do not undergo. Do not undergo. Because in D also, halogen is directly connected to double bond. Take this also. What about E and F? Yes. They readily undergoes. They readily, fastly. So that are not answers. They participate. But the question is do not. So these two are not the ones because they participate readily because they form stable carbocation. We are doing factors affecting SN1 and first nature of substrate. We are doing nature of substrate, right? No. Physics is over for you? Circle. See this. Which of the following alkyl halide readily participate in SN1? Like Chaitanya model questions, weekend questions. How they will frame the question. See. Which of the following alkyl halide readily participate in SN1? How to arrange these four in the increasing order of their reactivity? First of all, give the answer which alkyl halide readily participate in SN1. What I given to you, first what you have to do, remove halogen and observe the stability order. Remove halogen and observe the stability. You follow this trick. I am removing halogen from the first alkyl halide. Positive charge. From the first you are removing halogen, right? From the B, option B. Next, option C. This one. Remove halogen along with bonds. positive charge. Okay, and last one D. D no need to check. Why no need to check D? Tell me. Aryl halides do not participate, so that is least reactive. Now, how to check whether which alkyl halide readily undergo SN1 reaction? What I said, first remove halogen along with the bond. Halogen along with the bond. Here also halogen along with the bond. Halogen along with the bond. After that, compare the stabilities against GOC. Now we don't know GOC. That's why we could not answer. Clear? General thing only. Adiba, Obed, Saad. Which is stable carbocation? C. Here resonance is present. Look at this. Resonance is present. Resonance is present. But here also resonance is present. Na? Here also resonance is present. But resonance and 2 degree. Resonance and 1 degree. This is connected to 1 carbon. This dot connected to how many carbons? 1 carbon this side. But this dot connected to here 1 carbon and here 1 carbon. 2 carbons, right? This middle dot is connected to 1 and 2. Degree is more. This dot is connected to only 1 dot. That side oxygen is there. Take carbons to decide the degree. This dot is connected to only 1 carbon. Okay? Now this is stable. Resonance is present and as well as 2 degree. Next here resonance is present. Once watch the videos how to find in which resonance is present, in which resonance is not present. So this is more stable carbocation that will be formed by this alkyl halide. So this is readily participate in SN1 reaction. So what is overall order? C greater than, A greater than, B greater than D. D is least reactive because that is aryl halide. Okay. Next, which of the following readily participate in SN1? I do like this vertically, then I can explain easily. CH3, CH2, CH3, and option C. We can discuss infinite number of examples. Okay. Again, what is the procedure to decide the reactivity order? Remove Cl and observe the stability order. All of you remove Cl and observe the stability order. As usually follow the procedure. Okay. I'm taking first one. CH2Cl. Here CH3 is given. No? Can I write CH3 like this? Remove halogen. See, First of all, you have to find out alpha hydrogen. Alpha hydrogen. The carbon which is connected to benzene ring is called as alpha carbon, and hydrogen which is present on alpha carbon is called as alpha hydrogen. Okay, this is alpha carbon, alpha hydrogen, alpha hydrogen, alpha hydrogen. How many alpha hydrogens are there? 3 alpha hydrogens are there. Through hyperconjugation, like this shifting takes place. Like this shifting takes place. Like this also shifting takes place. In 3 different ways, electrons are reaching the carbocation and stabilizing the carbocation. If more is the number of alpha hydrogens, more will be the stability. Very simple thing. Observe alpha carbon and find number of alpha hydrogens on that. If more is the number of alpha hydrogens, more will be the stability. Hyperconjugation, general organic chemistry. Clear? That's why I said in every case we use GOC only. Start as soon as possible. Complete by tomorrow evening. Watch the videos, or if you have notes, then you can revise notes. No problem. Now, this is first. Let us analyze second one. Why second one is unstable? Second one forms unstable carbocation compared to this. What is second one? Take next page. CH2, right? Second one is CH2. Can I write like this? Right? Bhakti, tell me how many alpha hydrogens are there here? 2. This is alpha carbon. Alpha carbon. To this carbon, how many are directly attached? 2. So 2 alpha hydrogens we have. Like this, shifting takes place. Like this, shifting takes place. Only 2 alpha hydrogens are there. Here donation is less, so stabilization is less. But in the last case, 3 alpha hydrogens are there, so donation is more and stabilization is more. This is less stable carbocation compared to previous one. And last one, take directly last one. Yes, only 1 alpha hydrogen is present. Okay. Only 1 alpha hydrogen. Here 2 alpha hydrogens. If more is the number of alpha hydrogens, then more will be the stability. So which alkyl halide readily participate in SN1? A. Because A can form more stable carbocation. Got it, online students, all of you, everyone. Which of the following readily undergoes SN1? Benzyl chloride connected to OH. NH2. First of all, give the or select the alkyl halide which readily participate in SN1, then give the order of solution. NH2 is a plus M group, OH is a plus M group, this is also a plus M group, this is a minus M group, then minus M group. Sir, tell me. Sir, cheppandi. Hello. Sir. నేనేం అనలేదు, ఎప్పటిదో ముచ్చటది. ఓ పని చేయమనండి, 20%. సరే, నేను ఒక్క 5 minutes ఆగి చేయను, అయిపోతుంది క్లాస్. సరే, మీ స్టూడెంట్ ఇక్కడే ఉంది, లేట్ అవుతుంది తనకు మళ్ళీ. రైట్, plus m, where plus m is more. This is minus m, we can filter this least reactive because this form unstable carbocation. Minus m groups destabilize the carbocation. See, analyze, how to analyze, elimination method, eliminate this one, it is eliminated, right? Next, nitrogen is having lone pair, oxygen also having lone pair. Donation of lone pair is easy. Donation of lone pair is easy, but here hyperconjugation, you are sending bond pair electrons into the resonance. Clear? This is bond pair electron. Sending bond pair electron is difficult. Clear? You have to cut this bond. Okay. Resonance stabilization is more. Resonance stabilization is more than hyperconjugative stabilization. Okay. Okay. Lone pair resonance. In these two cases, lone pair resonance is there. Lone pair resonance compared to bond pair hyperconjugation. But NH2 and OH, which is a more plus m group. NH2, remember the order, plus m order. NH2 is a good plus m group. NH2 is a good plus m group than OH. OH is a good plus m group than CH3. Nitrogen is less electronegative, its donating capacity is more. Nitrogen is less electronegative, its donating capacity is more. So this compound forms a stable carbocation. That's why it readily participates in SN1. Plus m effect of NH2 is more compared to plus m effect of OH, and plus m effect of OH is more when compared with CH3. Clear? So now you can understand how the second year concepts link to first year